Welcome to Cosmic Bedtime, where the universe whispers, and curiosity drifts gently into wonder. Tonight, we follow a story unlike any other, a story of silence that sings, of darkness that hums. What does a black hole sound like? Can we truly listen to something that devours even light? And what happens when science gives us more than answers? It gives us music. In this episode, Sounds of the Black Hole, NASA's radio signals decoded, we embark on a soothing voyage through the cosmos, listening not with our ears, but with our imagination. Through NASA's sonification projects, we explore how the deepest parts of space reveal themselves not just through numbers, but through harmonies beyond words. So, lie back. Close your eyes. And let the music of the universe carry you away. In the vast theater of the universe, there is no sound, at least, not in the way we experience it on Earth. There is no air to carry the rustle of cosmic winds, no breeze to whisper through galactic branches. Space, by its very nature, is silent. It is a vacuum, a place where sound waves cannot travel, where shouting into the void results in nothing but stillness. And yet, we listen. Across the skies, humanity has built instruments that stretch their ears toward the cosmos. Giant radio dishes point up like metallic sunflowers, capturing whispers from faraway stars. Space probes drift in the cold, their sensors tuned to frequencies we can't hear. Computers hum as they process streams of invisible data, transforming numbers into images, light, and, sometimes, music. This story begins not with a bang, but with a whisper. A whisper from a place so strange, so mysterious, that even light cannot escape it, a black hole. Black holes have always fascinated and frightened us. They are the universe's deepest mystery, where gravity reigns supreme and time bends like soft clay. For much of history, they were theoretical phantoms, mathematical predictions that seemed too strange to be real. But now, we know they exist. We've even seen one, the shadow of a black hole, photographed by a global network of telescopes, glowing with light from the doomed material spiraling inward. Still, we ask, can something so dark speak? Can a black hole make a sound? The answer, surprisingly, is yes, but not in any ordinary way. Sound, as we understand it, requires air or water or solid ground to move through. But black holes emit waves of another kind, gravitational waves, radio waves, X-rays, vibrations not of air, but of space-time itself. These are not sounds we can hear directly, but signals we can translate. With the right tools and a little imagination, we can turn these waves into something our ears understand, music. It's not just noise. It's not random. It's something more profound. When NASA first released sonifications, audio translations, of black hole data, people were stunned. What emerged were eerie, otherworldly harmonies. Deep hums. Vibrating pulses. Melancholy drones that rise and fall like the breath of a sleeping giant. These were the echoes in the void, the voice of an object that should be voiceless. And people listened. Some felt wonder. Others, unease. Many felt a strange, unexpected emotion, like hearing the song of something ancient and alien, something that doesn't care if we're listening, and yet sings anyway. But why do we do this? Why turn data into music? Why assign sound to silence? Maybe it's because we are a listening species. From lullabies to love songs, from birdsong to Beethoven, we are creatures of rhythm and resonance. We seek patterns, meaning, emotion. When we hear a melody, we don't just hear notes, we feel something deeper. And so, when science gives us a string of numbers from a distant black hole, we translate it, not just to understand, but to feel. In that way, listening to a black hole becomes more than a scientific act, it becomes something human. The universe may be silent, but we are not. And in our silence, we reach out, shaping the sound of space into something we can hold. There is poetry in that. There is music in that. There is meaning in the echo. Imagine drifting alone through space, thousands of light years from home. All around you, silence. But then, through your radio, you hear it, a low vibration, slow and steady. Not a voice. Not a message. Just presence. Just existence. The heartbeat of the cosmos. In the chapters to come, we'll dive into how NASA captures these strange signals, how scientists and artists turn them into sound, and what those sounds mean, for science, for art, and for the human spirit. But for now, let's linger here. In the quiet. And listen. To the echoes in the void. In the boundless quiet of the universe, Earth is a small, listening ear. A speck of awareness floating in a cosmic ocean, surrounded by darkness that stretches in all directions. And in that darkness, we have dared to listen. For centuries, space was seen as a void, cold, silent, and still. A place where sound could not travel, because there was no air to carry it. But we learned something remarkable. While the vacuum of space holds no sound in the way we experience it on Earth, the universe is not truly silent. It hums. It pulses. It sings, in a language of energy, of waves, of signals that dance across the fabric of space and time. It was radio astronomy that first opened our ears to these cosmic whispers. By the mid-20th century, as radio towers bloomed across the Earth, humanity began to realize we could tune in, not just to each other, but to the stars. Giant dishes, tilted toward the heavens, began collecting invisible messages, low-frequency waves emitted by stars, planets, quasars, and black holes. Black holes. The very name suggests a place of absence, no light, no sound, no escape. Yet, paradoxically, some of the most intriguing signals in the universe come from the fringes of these gravitational monsters. Not because the black hole itself is speaking, but because the universe around it is shouting as it's being torn apart. NASA, alongside other international space agencies, began capturing these echoes. Not in sound as we know it, but in electromagnetic waves that could be translated, visualized, and heard. And when we convert those signals into sound, something astonishing happens. The inaudible becomes audible. The abstract becomes emotional. We begin to feel space. These sonifications, the transformation of data into sound, have given rise to an entirely new dimension of exploration. We can hear a black hole's gravitational pull distort space. We can listen to the steady pulse of a pulsar, beating like a cosmic metronome. We can immerse ourselves in the deep, resonant moans of matter spiraling into the unknown. The act of listening to the cosmos is not just scientific, it is spiritual. It invites us to sit quietly, and be present with a reality far greater than ourselves. To understand that the universe is alive with motion, with rhythm, with echoes from the dawn of time. And in this silence, where we expected nothing, we discovered a song. A song of gravity, heat, destruction, and creation. A song that reminds us that even in the coldest, darkest corners of the universe, there is movement. There is energy. There is a voice. We only had to learn how to listen. In space, silence isn't the absence of sound, it is the stage on which the universe performs its most haunting music. Out here, in the vacuum where molecules are too sparse to carry sound in the way our ears understand it, there are still vibrations. Movements. Rhythms. And they can be translated into sound waves, transformed, not into noise, but into song. It's not sound as we know it, but an audible mirror of celestial phenomena, born from electromagnetic waves, gravitational tremors, and quantum pulses. When NASA and other scientific institutions listen to black holes, they are tuning into this silent music. The data captured by telescopes, satellites, and arrays like Chandra or LIGO are frequencies of energy, oscillating with patterns shaped by the black holes themselves. Through a process called sonification, these frequencies are converted into sound. The gravity of a black hole pulling at surrounding gas becomes a low hum. The merging of two black holes, an event so violent it distorts space and time, resonates like the toll of some ancient cosmic bell. These are not fictional soundtracks added for dramatic effect, but real data translated into tones, tempo, and resonance. This symphony is unlike anything heard on Earth. It is eerie, deep, often unsettling, yet oddly beautiful. A reminder that while space may be silent to our ears, it is never still. There is something intimate about hearing the song of a black hole. It collapses the distance between the unimaginable and the familiar. A distant celestial monster, once only a concept or a math problem, now sings to us. And we, tiny beings on a pale blue dot, are able to listen. These sounds, whether recorded from the Perseus galaxy cluster or from binary black hole mergers, speak in a language beyond words. A kind of raw poetry, one that tells stories of mass and void, of violence and stillness, of the heartbeat of the cosmos. But it's not just about the black holes. It's also about us, our desire to reach across the emptiness, to translate the unknowable into something we can feel. In this way, the Symphony of Silence is both a scientific breakthrough and a deeply human act. It is music created not by instruments, but by gravity, gas, and genius. We are, in essence, composing with the universe. Listening to it. Letting it teach us how to hear again, not just with our ears, but with our imagination. And once you've heard it, that haunting, alien harmony, you'll never again think of silence the same way. As the cosmos hums with frequencies imperceptible to the human ear, a new kind of listening is required, one that reaches far beyond the biological limits of our senses. If black holes truly sing, then it is not with vocal cords but with gravitational ripples and electromagnetic echoes. And to hear them, we must extend ourselves through machines, machines crafted not to shout into the darkness, but to listen. These listening machines are NASA's radio telescopes. They are the ears humanity has built to hear the silence of space. Long before we could truly understand what a black hole was, we were already building the tools to hear one. The story of these tools began in earnest in the mid-20th century, when radio astronomy, still in its infancy, began to show us that the universe was not a mute void, but a landscape alive with radio waves. Radio telescopes do not look like the telescopes of Galileo's age. They are vast dishes, some spanning the length of football fields, not built to see light, but to capture whispers, radio signals, often billions of years old, gently washing over Earth. These signals are faint, delicate. The cosmos speaks softly, and only patient, careful ears can catch its voice. NASA's Deep Space Network, DSN, established in 1963, is one of the most important sets of those ears. With sites in California, Spain, and Australia, strategically placed to ensure continuous coverage as Earth rotates, the DSN can listen to deep space 24 hours a day. It was created to communicate with distant spacecraft, but as missions evolved, so too did its purpose. The DSN began to listen to the stars themselves. It listens for spacecraft transmissions, yes, but also for cosmic noise, quasars, pulsars, nebulae, and, more recently, the enigmatic frequencies from black holes. It listens not just to what we send out, but to what space sends back. Listening to a black hole is not as straightforward as tuning into a radio station. A black hole emits no light and no direct sound. What we call hearing a black hole is in fact a process of interpreting data collected from the matter around it, gas spiraling inward, magnetic fields twisting violently, and the intense friction that creates powerful X-rays and radio emissions before matter disappears beyond the event horizon. NASA's Very Large Array, VLA, nestled in the quiet deserts of New Mexico, is another crucial set of ears. With 27 antennas arranged in a vast, Y configuration, the VLA operates as a single telescope, capable of capturing astonishingly faint radio waves from distant corners of the universe. In 2019, it was one of the instruments used to observe the supermassive black hole at the center of the galaxy M87, the same one imaged by the Event Horizon Telescope. But while the famous image showed us the glowing ring of gas and shadow, the VLA was among those who heard it, recording radio emissions from the edges of that hungry abyss. This listening process is subtle and complex. The VLA doesn't capture sounds in the way a microphone would. Instead, it gathers data about radio waves, frequencies far below the visible spectrum. These waves are digitized, processed, and often transformed, not to deceive us, but to allow us to understand. Sometimes, that transformation takes the form of music. In recent decades, NASA has begun to lean into a new frontier, sonification, the practice of turning scientific data into sound. It's not a gimmick. It's not pseudoscience. Sonification helps us perceive patterns in data that might otherwise be hidden, especially for visually impaired scientists and for anyone who finds meaning not in graphs, but in rhythm, tone, and resonance. NASA's Chandra X-ray Observatory, which peers into the universe using high-energy X-rays, has become one of the frontrunners in sonifying black hole environments. Working with the Smithsonian Astrophysical Observatory, Chandra has helped create audio experiences of real cosmic phenomena. The black hole at the center of the Perseus galaxy cluster is one of the most famous examples. In 2003, astronomers using Chandra discovered pressure waves rippling through the hot gas surrounding the black hole, essentially sound waves, albeit on an unimaginable scale. These waves had a frequency of 10 million years per cycle, so low they were effectively silent. But when NASA scientists scaled the frequencies up by many octaves, bringing them into the range of human hearing, they discovered a haunting, deep moan. A cosmic drone. A sound that, once you hear it, never quite leaves you. It was one of the first instances in which the voice of a black hole was made audible. Not because black holes make sound in the way humans do, but because we were finally able to hear what the universe had been saying all along, in its own language. NASA's radio ears are more than just tools, they're part of a broader philosophy. They represent our desire not just to see the cosmos, but to feel it, to interpret it through different senses. In a way, they are extensions of our own bodies, built to perceive the imperceptible. Consider the James Webb Space Telescope. Though primarily known for its infrared imaging, it too is a listening machine of sorts, not in the audio spectrum, but in the sense that it receives. It absorbs. It decodes the whispers of ancient galaxies, redshifted into the long, slow waves of time. While it does not hear black holes in a musical sense, it contributes crucial information about the matter around them, about the silence before the song. Together, these instruments, Chandra, VLA, DSN, JWST, form a kind of symphony orchestra. Each plays a different role. Some gather high-pitched radio frequencies. Others observe the gravitational pulls. Some see in X-rays, others in long waves. And when their data is combined, something extraordinary emerges, a kind of cosmic composition, built not on guesses, but on evidence. In recent years, artificial intelligence has begun to play a role in decoding the language of space. AI systems, trained on mountains of data, are now helping astronomers detect patterns, anomalies, and signals that human eyes might miss. One such project involves converting gravitational wave data into soundscapes that AI can analyze for unusual structures, possible evidence of exotic objects, or even previously undetected black holes. The more we listen, the more we learn. And the more we learn, the more we begin to suspect that the universe isn't silent at all, it's simply been speaking a language we're only beginning to understand. What, then, is the purpose of all this listening? Is it purely scientific? Certainly, part of it is. We want to understand the birth and death of stars, the structure of galaxies, the behavior of extreme gravity. But beneath the science is something more human, the longing to feel less alone. To hear the cosmos is to connect with it. It is to bridge the infinite gulf between ourselves and the stars. These sounds, these processed, translated whispers from the void, do something no telescope image can quite do. They touch us. They bypass logic and go straight to the heart. It is no accident that many of NASA's sonification projects have found homes not just in scientific conferences, but in museums, art galleries, and even music festivals. They live where science meets spirit. They remind us that space is not just something to observe, it is something to listen to be moved by. And in the darkness of a world that often feels chaotic and disconnected, the soft, slow music of the cosmos becomes something else entirely. A reminder that even in the silence, there is song. The night was still. Across vast oceans of vacuum, a signal arrived, not with the clarity of a spoken word, nor the melody of a song, but with the trembling suggestion of presence. A whisper from the dark, long silenced by distance, time, and gravity. Yet now, with our instruments finely tuned and our minds finally open to the possibility of hearing what once was thought unhearable, we listened. And for the first time, the black hole spoke. Not in language, not in intention, but in vibration, rhythms traced in X-rays, gravity, and light bent into nothingness. These were not the kind of whispers that traveled through air or sound waves. These were the whispered patterns in radiation fields, the echoes in the curvature of space-time, the murmurs of energy devoured, twisted, and flung out across the cosmos. In the early 2020s, scientists at NASA's Chandra X-ray Observatory and other international space agencies began collecting extensive data on the Perseus galaxy cluster, a region over 240 million light-years away. Hidden in its core was a supermassive black hole, a titan cloaked in silence. But in 2003, researchers discovered something strange. The data collected showed ripples, literal pressure waves, moving through the cluster's hot gas. These ripples corresponded to a very low-frequency sound wave. Far too low for human ears, these waves had a period of about 10 million years per cycle. If a black hole could hum, this was its tune. Still, for years, it remained a scientific curiosity. Not until sonification, a method of converting data into sound, was more fully embraced, did this humming find a voice humans could perceive. Using sophisticated algorithms, researchers took the radial waves from the black hole and scaled them up. What was once too deep, too slow, too vast to be heard, became audible. For the first time, we didn't just observe a black hole. We heard it. The result was haunting. Imagine a deep, alien moan, neither mechanical nor organic. A slow, rising tremor of sound that feels less like a note and more like a warning. A cosmic breath. A sorrowful chant vibrating through eternity. It wasn't a scream. It wasn't thunder. It was something deeper, something resonating with the hidden structures of the universe. Some described it as mournful. Others said it sounded like the universe sighing. But perhaps the most striking reaction was the simplest one: people felt small. Listening to the sounds of the Perseus black hole was like standing at the edge of a storm you cannot see, a storm too large and too ancient for comprehension. There's a reverence that descends when faced with something so immense, so utterly beyond the human frame. In those frequencies, those vibrations, was the fingerprint of a place where time bends and matter forgets itself. Where stars die. Where light ends. And now, it had a voice. Why do these sounds affect us so deeply? There's something primordial about deep frequencies. Thunder, earthquakes, the rumbling of mountains, all evoke instinctual reactions in us. These aren't the sounds of comfort. They're the sounds of awe. Of warning. Of reverence. Our ears evolved to hear danger, to detect shifts in the environment. But now, they're catching the echoes of a different kind of landscape, the terrain of collapsing stars and devouring gravity. These sounds are not for survival. They are for understanding. The black hole's whisper reaches us not only through science, but through emotion. It confronts us with the unknowable, and in doing so, reminds us of our own limits, and our astonishing curiosity. We're not afraid to listen. We're compelled to. Drawn into the void, not out of fear, but out of wonder. It's easy to forget that these whispers began as cold numbers, raw data, pixel values, energy readings, patterns invisible to the human mind. But through the alchemy of sonification, we transformed them into something intimate. Something close. It's like hearing a memory from a childhood you never had. Something ancient and deeply unfamiliar that nevertheless stirs the part of you that dreams. This transformation wasn't just a scientific achievement. It was poetic. It allowed us to have a relationship with something we cannot touch or see. It made the untouchable feel present. Some scientists began to refer to these sonifications as acoustic portraits. Not mere translations, but interpretations. Art drawn from gravity. Emotion born from mass and void. One of the most profound aspects of the first whispers from a black hole is what they reveal about us. About the human soul. We turned our telescopes to the stars, not just to see, but to feel. We developed instruments to listen, not because we expected music, but because we hoped for meaning. And when we heard that ghostly hum from Perseus, we didn't just react with curiosity. We reacted with emotion. People wept. People created music inspired by it. Filmmakers used the sounds in space documentaries and science fiction. Artists painted it. Children asked if the universe was singing to them. It stirred a kind of cosmic intimacy that no image, no graph, no equation could achieve. It reminded us that the universe is not dead. It's alive in ways we are just beginning to perceive. And it is speaking. Quietly. Softly. But speaking. As more data from other black holes came in, the process repeated: capture, convert, interpret, feel. The first whisper led to many more. And each one seemed to sing its own song, different in rhythm, tone, and mood. No two were alike. Just like no two stars are alike. But the first one, Perseus, remained special. Like the first heartbeat heard in an ultrasound. The first word spoken by a child. The first moment when a great silence broke, not with noise, but with presence. It was a beginning. And beginnings echo forever. We often think of black holes as the ultimate void, a place where even light cannot escape, and certainly not sound. But in a universe that follows the laws of physics like a carefully composed score, even silence has structure. And that structure can sing, if only we know how to listen. Sonification is the process of turning data into sound. It's not science fiction. It's not metaphor. It's a legitimate and increasingly powerful way to explore the cosmos, especially in environments where traditional imagery fails us. When light cannot escape, when visuals reveal little, sonification offers a new lens. Or rather, a new ear. When NASA's Chandra X-ray Observatory captures X-ray emissions from the Perseus cluster, the result isn't an image in the traditional sense. It's a stream of high-energy data, pressure waves rippling through hot gas, traces of ancient collisions and slow-moving gravitational ballet. These are patterns that the human eye can't perceive. But with sonification, they can be translated into something we can perceive: sound. Take, for example, the infamous black hole sound released by NASA in 2022. This wasn't a live audio recording, of course, there are no air molecules in space to carry sound the way we know it. Instead, scientists took the pressure waves emitted from the black hole at the center of the Perseus galaxy cluster and scaled them up by 57 octaves to fall within the range of human hearing. The result? An eerie, otherworldly moan. A deep, resonating hum that speaks more to the soul than to the intellect. It's not just noise. It's a message, perhaps not meant for us, but now intercepted, interpreted, and transformed. The act of sonifying space requires interpretation. And like any translation, it involves choices. Which data do you amplify? Which signals are foreground, and which ones fade into silence? There's a strange subjectivity here, not in the data itself, but in how we shape it for human ears. This isn't new. Scientists have long converted radio waves, seismic activity, and even cosmic ray counts into sound to reveal patterns otherwise invisible. Earthquake data becomes a symphony of thuds and trembles. Solar flares crackle like static. And gravitational waves, those ripples in spacetime predicted by Einstein, become brief chirps that mark the collision of massive objects light years away. In each case, we are not fabricating sound. We are revealing it. Sound, at its core, is vibration, and the universe vibrates constantly. There's something poetic in how we choose to sonify black holes. Because in doing so, we're reminded that the universe doesn't have to look beautiful to be beautiful. It can sound beautiful too, and sometimes, in that sound, there is a deeper truth. For instance, in the sonification of data from the black hole at the center of M87, the same one that gave us the first black hole image in 2019, astronomers turned brightness and position into pitch and volume. The brighter the source, the louder the tone. The closer to the center, the deeper the note. What emerged was a slow, almost meditative tone. It didn't sound like chaos or destruction. It sounded serene. As though, at the heart of gravity's fiercest grip, there was stillness. Not the absence of motion, but a kind of harmony beyond our understanding. In many ways, sonification blurs the line between science and art. The astrophysicist becomes part composer, part translator, part philosopher. And the listener, whether scientist or student or simply someone curious, is invited into a new kind of relationship with space. It's a quiet rebellion against the idea that knowledge is cold, clinical, or detached. When you hear the sounds of a black hole, you're not just understanding it. You're feeling it. Its presence becomes emotional, not just factual. And that may be one of the greatest gifts of this technology, not only helping us understand what's out there, but also reminding us of who we are. Creatures of pattern, of rhythm, of meaning. We were born listening to a heartbeat. No wonder we find comfort in the music of the stars. The sonification of black hole data is still young. Tools are improving. Interpretations are evolving. What began as scientific outreach is now informing actual research, helping scientists detect subtle patterns, anomalies, or signals buried deep in the noise. But beyond the labs and observatories, there's a growing community of artists and musicians who are weaving these cosmic tones into compositions. For them, these sounds aren't just scientific curiosities. They are echoes of something ancient, something infinite. something sacred. Imagine listening to the remnants of a star that died before Earth was born, and realizing that its final cry, buried in gravitational waves, now flows through your headphones. Imagine being part of that story. That's what sonification offers us, a way to feel our place in the universe, not through sight, but through sound. And sometimes, the deepest truths don't need to be seen. They need to be heard. There are moments in science when data becomes something more than numbers. When a graph can feel like a sigh. When a signal, filtered through frequencies beyond our perception, becomes a whisper that bypasses language altogether. This is one of those moments. The sounds we extract from black holes, these strange, echoing pulses and long, drawn-out howls, carry no semantic meaning. They're not words, not sentences. They aren't trying to say anything. And yet, somehow, they speak to us. They stir something in us that predates language. Something elemental. Ancient. We hear the rising and falling tones and are reminded of breaths, of life, even in the void. We hear deep vibrations and think of heartbeats, of time passing. And when the pitch rises or fractures, we feel tension, curiosity, or awe, even though no one ever taught us how to interpret such things. The universe is not speaking in words. It never has. And maybe, just maybe, the most profound conversations are the ones beyond language. There's a kind of paradox here. A black hole, by definition, is silent. It lets nothing escape, not even light. And yet, through indirect measurement, gravitational waves, X-ray fluctuations, the bending of space, we have found a way to hear it. The irony is poetic. NASA's sonifications don't give us information in the traditional sense. Instead, they give us experience. An emotional translation of an otherwise cold phenomenon. They bypass the analytical parts of our brain and head straight for the heart. It's not that we understand more about black holes when we hear their translated sounds. It's that we feel them differently. More intimately. As if the universe, for a fleeting moment, allowed us to place a stethoscope to its chest. Music and sound are perhaps the closest we get to a universal language. Cultures around the world, throughout history, have used melody and rhythm to convey what words cannot: grief, joy, transcendence. When we listen to the songs of black holes, we're not just engaging with astrophysics, we're engaging with a form of cosmic music. A music not composed by humans, but by the laws of gravity, by the swirling of matter and the distortion of space. It reminds us that beauty doesn't require intention. It exists in the movement of planets, in the orbit of galaxies, in the collapse of stars. And when we slow it down, shift it, map it to the range of human hearing, we realize that even chaos has rhythm. Even destruction can have harmony. In the lab, the signals are just data points. They're graphed and plotted, categorized and peer-reviewed. But when those data are converted into sound, something transforms. They become stories. Not in the way we usually tell stories, with characters and arcs and endings, but in a deeper way. In a way that's closer to dreams or memories. Something abstract, but deeply personal. One person might hear the sounds of a black hole and think of loneliness. Another might hear serenity. Others might feel a strange comfort, as if the universe is humming a lullaby too vast to fully grasp, but too gentle to ignore. These reactions are not wrong. They're simply human. Maybe that's the real message hidden in these sounds, not from the black holes themselves, but from our own interpretations. The way we respond to these tones tells us something about us. About how we relate to the cosmos. About what we seek in the silence. Some hear beauty. Others hear fear. Still others hear curiosity or reverence. And in this variety, we find the richness of our species, a tapestry of interpretation woven from millions of quiet listeners, all tuned to the same faint frequencies from beyond the stars. There's something deeply moving about that. Because even though black holes have no voice, we've found a way to listen. And in doing so, we've added our own layer of meaning, human meaning, to the fabric of space and time. In the end, the sounds of black holes aren't about the black holes. They're about us, about our longing to connect with something greater, to hear music where once there was only math, to turn cold equations into warm echoes. And perhaps most importantly, they remind us that the universe is not silent after all. It's singing. We just had to learn how to listen. The universe has never spoken in words, nor painted its emotions with a human brush. And yet, when we listen to the sounds translated from the depths of space, from the haunting groans of black holes to the rhythmic pulses of pulsars, something inside us stirs. These are not random noises or data plots anymore. They become something else entirely, they become feeling. We don't expect science to be emotional. We expect formulas, constants, numbers that describe, not provoke. But what happens when a black hole's gravitational waves are turned into a low, wavering rumble that resonates like a distant cry? Or when a cluster of galaxies becomes a shimmering harmonic tone? We find ourselves not only analyzing, but feeling. As if the universe were singing something ancient, something meant for us, not in words, but in moods. This is where sonification breaks its scientific mold and touches the soul. Sound, as a human experience, is deeply tied to memory, to emotion, to instinct. A single note can recall an entire lifetime. A melody can bring tears. And now, as we apply this power to the cosmos, we begin to connect, not just understand. Black holes are no longer distant and indifferent objects. They are performers in a universal orchestra, drawing from a music we were never meant to hear, until now. When NASA released sonified versions of black hole data, many listeners described the experience as haunting, calming, mournful, or beautiful. These weren't technical reviews. They were emotional reactions, from people who had never before considered space to be something that could move them. And yet, move them it did. This emotional connection is not accidental. It's built into the very way we process sound. Frequencies become textures. Vibrations become voices. We assign meaning to tone, pitch, tempo. Even silence has weight. When the sound of a supermassive black hole in the Perseus galaxy cluster was transposed into the human hearing range, what emerged was a ghostly echo, layered and resonant, like the sigh of a cathedral-sized whale drifting in endless night. It was beautiful, and profoundly unsettling. It made space feel lonely. It made space feel alive. And therein lies the paradox. In trying to make space more understandable through sound, we made it more human. We projected our own inner world into the void, not to colonize it, but to connect with it. We made the universe emotional not because it is, but because we are. And in doing so, we glimpsed a truth that science alone often hides, that knowledge is not just about knowing. It is about feeling, too. The emotional universe is not separate from the real one. It's an extension of our relationship to it. Every chart and spectrum, every measurement and map, becomes more profound when it stirs us, when it reminds us of the silence we come from and the music we carry inside. The sounds of black holes may be born of mathematics and motion, but what we hear, truly hear, is something much deeper. We hear ourselves, reflected in the darkness. And maybe, just maybe, we're starting to hear the cosmos listening back. There comes a moment in every journey of discovery when the boundaries blur, when the rigid lines of science soften into the brushstrokes of art, and the precise measurements of data begin to whisper something more. With the sonification of black hole signals, we find ourselves at such a crossroads. What began as an effort to understand has become a way to feel. In the early days of astrophysics, our tools were telescopes and mathematics, our outputs charts and graphs. But now, we are creating something new, not just images or equations, but experiences. Through sonification, scientists are not merely translating data, they are inviting us to inhabit it. To live inside the rhythm of gravitational waves. To hear the invisible. To feel the mathematics not as numbers, but as emotions. Some of these sonified black hole recordings are simple, the low hum of a deep gravitational well, the rising pitch of a star being torn apart, the rhythmic pulse of matter spiraling inward. Others become elaborate compositions, layered and textured, as if the cosmos itself were performing a quiet symphony. And people listen. Not just scientists or astronomers, but artists, composers, poets, dreamers. They listen, and they respond, not with equations, but with music, with paintings, with dance. A pianist reinterprets the waveform into notes. A painter translates the frequencies into hues. A dancer choreographs the curvature of space-time into movement. Suddenly, black holes are not just studied, they are performed. This is more than outreach. It is communion. In classrooms, students hear the sound of a black hole merger and respond with awe, not because they understand the physics, but because they feel it. In galleries, visitors press headphones to their ears and close their eyes, transported not to a place but to a presence. In quiet bedrooms, someone listens to the whispers of the void and finds peace in its stillness. Science has always sought to explain the universe. Art has always sought to express it. And now, through sonification, we are finding a bridge between the two. There's something poetic in the idea that gravity, the most silent of forces, can be made to sing. That lightless voids can produce something beautiful. That what we once thought of as terrifying, black holes that devour and erase, can be recast as creators of music, as composers in the symphony of the cosmos. This convergence is not accidental. It is a reflection of who we are. Humans are not just logical or emotional, analytical or artistic, we are both. We chart the stars and we write songs about them. We measure the distance between galaxies and then we whisper to the night sky. We launch satellites and build symphonies from their signals. We are creatures of curiosity and creatures of feeling, of science and art. And so, when we hear the sounds of black holes, we are not just hearing data, we are hearing ourselves reflected back through the vastness. The sonification becomes a mirror, and in it, we see both the mind and the heart. The logic of physics and the lyricism of wonder. It's a reminder that science does not exist in isolation. It is part of a larger human story, a story of searching, of reaching, of feeling. And sometimes, the most profound discoveries are not those that teach us something new, but those that remind us what we already know deep down. That we are not separate from the universe. We are part of its music. In the end, perhaps what we hear in the black hole's voice is not just sound, but something far deeper, a reflection of the cosmos within ourselves. This isn't merely about radio waves, sonification, or astronomical data. It's about finding music in the patterns of existence. A way of understanding that behind the complexity of equations and gravitational waves, behind the darkness and silence of deep space, there is still rhythm, still harmony, still art. When NASA transforms the dance of matter and time into sound, they are doing more than translating. They are revealing something profoundly human. That even in our most scientific pursuits, we are artists at heart, storytellers, composers, listeners. Each vibration from a black hole is like a cosmic drumbeat, a reminder that even in collapse, there is form. Even in silence, there is resonance. Even in the most alien forces of the universe, there is a strange and unexpected familiarity. And isn't that what all music is, at its core? An attempt to make sense of the world. To find structure in chaos, to give emotion to the inexpressible, to bring people, separated by time, culture, and distance, together for a shared experience. So when we hear the sound of a black hole, we are not just listening to a distant celestial object. We are listening to ourselves. To our curiosity, reaching across light years. To our creativity, sculpting meaning from data. To our solitude, longing for connection. To our awe, standing at the edge of comprehension. And in that moment, we realize that we are part of something infinitely larger, a symphony without a composer, a melody that has been playing long before us and will continue long after. The universe does not play favorites. It does not speak in human language or adhere to human values. But it sings. In gravity, in light, in time. And we, tiny and transient though we may be, have somehow learned to listen. In a way, this is humanity's quiet triumph. We have taken the deepest darkness and turned it into music. We have turned listening into discovery. We have turned science into art. And perhaps, by listening more deeply, whether to the stars or to one another, we will continue to uncover beauty in places we never thought to look. Because maybe, just maybe, the music of everything has always been playing. We just needed the courage to press play. And so, dear dreamer, as the final echoes of black holes fade into the stillness of your room, may you carry with you the quiet wonder of a universe that hums and sings in the silence. From invisible waves to haunting melodies, the cosmos has always been whispering. All we needed was a way to listen. If this journey brought you comfort, sparked curiosity, or simply made the night a little gentler, we invite you to join us again. Subscribe to Cosmic Bedtime for more stories that drift softly through science, space, and the soul. Leave a comment if something in the sound of the universe touched your heart. And share this with someone who needs a moment of calm in the vast, chaotic world. Until next time, may your dreams be filled with stardust, and your nights echo with the music of everything. Good night.